everyone. My name is Amjad Alghamdi. I'm a computer scientist from Imam Abdulrahman bin Faisal University, and I will present a comparison between Vgg16 and Xception model used as an encoder for image captioning. Well, I will first start with introduction, then I will explain what is the result of the related work. Then I will move to the materials and method, and I will discuss the experiment with its result and discussion, and our conclusion in future work. Well, image captioning considered one of the most challenging and important topics that fall in the intersect between computer vision and NLP. Our image captioning generator model followed the encoder-decoder architecture. And this architecture has shown much improved outcome in generating natural language description that contain a description of what the image actually contains. Our study reviewed the current advancement of image captioning model and summarize the underlying framework. It also contains the comparison of the performance of two different encoder model named Vgg16 and Xception. The purpose of the related work is to gain an understanding of the recently published paper that is related to our field, which is image captioning. And after revising multiple related work, we have provided a brief overview of image captioning advancement over the last 5 years. And we have illustrated the prevalent techniques in image captioning, and also we have summarized the result. And so far, there is no published study that do compare between Vgg16 and Xception model, which make our model or our paper unique. And now I'll explain the implementation process. It's contained or it was organized in 3 parts, starting with data preprocessing or dataset preprocessing, then the encoder-decoder framework, and finally is the result of the experiment. For dataset preprocessing, Flickr 8K dataset was used. It consists of 2 different folders. The first folder contained only images, and the second contain text file with the image description. In this phase, we worked on data cleaning. We convert all the letter to a lowercase letter, and we remove all the punctuations, and we also remove the word with 1 character to get rid of unhelpful part of the data. And for the encoder-decoder model, the CNN model was used. And for the decoder, LSTM model was implemented. For the comparison, we tested and evaluated 2 different encoder models, and based on the literature review, Vgg16 model is one of the most preferred CNN, as it has a very uniform architecture. And also Xception model is an extension of Inception model, and it's also considered a type of CNN model, but a better enhanced version. And finally, LSTM model is a modified and enhanced RNN model. Now, after the very brief explanation about both encoder and decoder used in this work, it's now time to explain the result of the experiment. The table shown each model performance in terms of a blue score, which is a matrix that is used to evaluate the performance. Also the testing loss of the implemented model, and the number of the epoch with the optimizer if used. As shown in the slide, the exception with optimization, which is Adam optimizer, outperform the other model, as it's the highest blue score, as you can see, which is 0.55. Both Vgg16 without optimization and Xception with Adam optimizer have a very similar score. However, the loss of the Vgg16 without having any optimizer is less than the exception with optimizer. I thought the loose number is still high even after implementing Adam optimizer in case of exception model. When we compare it to the remaining model, it still shows his ability in generating caption with the best probability and more accurate caption, unlike the caption that was generated with the other models. They were long sentences when we compare them to exception. And we can infer after all these experiments that in most situations, we found that the short sentences are sufficient to explain what the image contains, whereas the lengthier sentences frequently contain duplicate information and grammatical errors. And finally, the outcome of the comparison showed that the exception model, when implemented Adam optimizer, will generate the most accurate caption comparing to the other model. Hence, the experiment result will show a clear agreement to the conducted literature review. And for the future work, we plan to use a large data set that will enhance the model performance. And that's all, and thank you all for listening. Do you have any questions?